This is an AS Further Statistics 1 question on discrete random variables. A fair six-sided black die has faces numbered 1, 2, 2, 3, 3 and 4. The random variable B represents the score when the black dice is rolled. Part A, what we want to do is to write down the expected value of B, E of B. Now notice here it says write down. Now, if a question says write down, that means I'm not expecting to do any working. But to help me see what's going on, I am going to write down the probability distribution for B. That's that little table. And see how I can use this table just to write down the value of E of B. So our outcomes are 1, 2, 2, 3, 3 and 4. And the probabilities of each one of those is 1/6. So they're all going to be 1/6 because the question says that this is a fair six-sided die. So we'll put 1/6 in the bottom of the table. I don't need to calculate E of B. So it should be possible to work out E of B by symmetry, and it is. I've got symmetry of the probabilities, I've got symmetry of the outcomes. So there's a sort of line of symmetry between the 2 and the 3. So I can just write down that E of B is equal to 2.5, and I'll put down here by symmetry. You may have known that without drawing the table, but I always like to draw the table just to ensure that I get the value correct and I can physically see what's going on. Okay, let's have a look at part B. A white die has 6 faces numbered 1, 1, 2, 4, 5 and C, where C is greater than 5. The discrete random variable W represents the score when the white die is rolled and has probability distribution given by, we've got this table here, so the outcomes are 1, 2, 4, 5 and C, where C is greater than 5, and the probabilities are A plus B, A, 0.3, A and B. Greg and Nalia play a game with these dice. Greg throws the black die and Nalia throws the white die. So Greg, here, this table here represents Greg's black die, and then this table down here represents Nalia's white die. Greg wins the game if he scores at least 2 more than Nalia, otherwise Greg loses. The probability of Greg winning the game is 1/6. What we need to do is to find the value of A and the value of B, and we need to show our working clearly. Okay, now the first thing is we're going to need 2 equations because we have 2 unknowns. One equation is going to come from the fact that the sum of all the probabilities is equal to 1. So A plus B plus A plus 0.3 plus A plus B is going to equal to 1. So we can simplify that. We've got 3 A's and we've got 2 B's, and then if I take away 0.3 from both sides, I'll get equal to 0.7. So that's just simplifying what we have there. So here's my first equation that I can use to find A and B. Now to find the second equation, I need to use this information here about Greg winning. He will win if he scores at least 2 more than Nalia, because I know the probability of Greg winning. Okay, so let's write that down. The probability Greg wins is equal to 1/6. Now let's work out when Greg is going to win. So I'm going to do a little table here. Greg and Nalia. Right, let's think about this. Greg's score needs to be at least 2 more than Nalia's score. Here are the scores that Greg can get. So if he gets a 1, that's no good. He's not going to win because that's not 2 more than any of Nalia's scores. Also, if Greg gets a 2, that's no good because that is not 2 more than any of Nalia's scores. However, he can win if he gets a 3 and the liar gets a 1. So that's one way that Greg can win. If he gets a 3 and the liar gets a 1, that's at least 2 more than the liar score. He can also win if he gets a 4, his outcome here, and the liar gets a 1. He can also win if he gets a 4 and the liar gets a 2. So these are the only ways that Greg can win. And I'm going to use this to form some equations. Now let's write down the probabilities of these different things happening. So for Greg to get a 3, there's a 2 out of 6 chance of that. For Nalaya to get a 1, her probability is A plus B. For Greg to get a 4, that's 1 out of 6. Again, Nalaya to get a 1, that's A plus B. And then 1 over 6 to get a 4. And to get a 2, Nalaya's probability is A. So Greg will win. It will be 1/6 if Greg gets a 3, 2 over 6, and Nalaya gets a 1, A plus B. Okay, so I'll times them together. Plus, because there's a different way you can win. So or 1/6 times by A plus B, or the third way is going to be 1/6 times by A. Let's simplify this. So you've got 1/6 is equal to, and then if I expand the brackets, I guess if I write this 2 over 6 as a third, I will have a third A plus a third B. Then from the second bracket, I will have plus 1/6 A plus 1/6 B plus 1/6 A. Simplifying this, I've got a third A plus a 6A plus another 6A, so that's going to be 2/3 A. And then for my B's, I've got a third B plus a 6th B, so that is a half B, and that's going to equal 1 over 6. So I'll highlight this in yellow. This is my second equation, which I'm going to use to find the values of A and B. Now I'll use my calculator to solve those simultaneously, and I will get a value of A equal to 0.1, comes up as 1 over 10, and a value of B as 1/5, which I can write as 0.2. Part C. The random variable x is equal to 2w minus 5. Given that e of x is equal to 2.6, we want to find the exact value of var x. Now, there's several steps we need to do. So we've been given some coding here. I've been given e of x, and I know that e of x is going to equal to 2 times by e of w. So let me just highlight the coding that we're using. That's just here. So in the coding formula here, a is going to be 2, b is going to be -5. Yeah, so 2 times by e of w minus 5. And then for the variance of x, which is what we need to find, that will be a squared, so 2 squared, times by the variance of w. So I can find the mean of w from this table, and if I can find the mean of w, I can use it to find the variance of w, and then use that to find the variance of x. So I can just rearrange this formula to get the mean of w, use that to find this value of c. So let's do that first. Let's work out what the mean of w is. So e of x, is equal to 2.6. Actually, what I'm going to do is rearrange this formula first to make E of W the subject. So E of W is going to equal to E of X plus 5 all divided by 2. E of X is 2.6. I add 5, divide that by 2. So I've got a value of 7.6, which needs to be divided by 2, and that's 3.8. So that's E of W. Now we can complete this table. Well, I can complete the probabilities because I was given the values of A and B, or worked out the values of A and B from part B. So I can put these probabilities in. So probability that W is equal to 1 is going to be 0.3. So let's put 0.3 in. Next one will just be 0.1. 0.3 is given, then another 0.1, and then 0.2. Let's now see if we can calculate the value of C. So E of W is going to be equal to 1 times by 0.3 plus 2 times by 0.1 plus 4 times by 0.3 plus 5 times by 0.1 plus C times by 0.2, which is equal to this 3.8, which I've just calculated. Okay, if we do these multiplications and add them up, we'll get 2.2 plus 0.2C is equal to 3.8. We'll take away 2.2 from both sides, then divide both sides by 0.2, and we get a value of C which is 8. Now, I guess that is consistent with the piece of information that we were told earlier, which is C is greater than 5. So we'll put that in the table 8. And our next step is now going to be to calculate the variance of W, because once we've got that, we can find the variance of X. Okay, so var W, remember, is going to be E of W squared minus the mean squared, E of W all squared. We have E of W already, which is the 3.8. It's just about working out E of W squared. So that's going to be 1 squared times by 0.3 plus 2 squared times by 0.1 plus 4 squared times by 0.3 plus 5 squared times by 0.1 plus 8 squared, what we've just worked out for C, times by 0.2. That's E of W squared minus the mean squared. So we're going to be subtracting 3.8 all squared. Right, let's work that out and see what we get. So we got 20.8 minus 3.8 squared, which is 6.36. So remember, this is var W. var X is going to be 2 squared times that, so 2 squared times by 6.36. So let's do that now, and we get a value of 25.44. Now it does say the exact value, so we're not going to round this off. We're going to keep that full answer.